Hey guys, it's Professor Watson here. So this video is to help you guys work through your homework. So you guys have 40 problems this week. That's a lot of work. But when you really break the problems down, what you're doing is you're solving for one of our 5 variables. And so you'll notice in D2L in week 6, I have put this document that we're going to be working off of there for you. It's a Word document, so you can edit it if you like. And all I did is I put in the inputs and how to solve each of the questions. And the questions actually are questions exactly from your homework. I just changed some of the inputs for you. So we're going to work through about 13 questions here in this session to kind of better help you understand that homework, as I know that these are some pretty new concepts for you. So let's go ahead and get started. So you can pull up your document that is online. And so let's start with question number 1 on your practice problem set. So this question looks a lot like on your homework questions 1, 10, and 23. And I just put that reference up there for you. Looking at questions 1, 10, and 23, you can kind of have a little bit of a reference to come back to. So question number 1 says if you deposit $4,000 into a bank account that pays 10% interest annually, how much will be in your account after 6 years? So I've broken out the problem for you already. The solution is there, but let's just step through this real quick. Pretty straightforward with this one. It's just a future value problem. My N is 6. My IY is 10. That's my interest rate. My present value is a negative 4,000 because that's what I'm depositing into the bank, so that cash flow is negative to me. We don't mention anything about a payment in this question. And when we go ahead and solve in our calculator, our future value is $7,086.24. So we can come quickly over to our calculator here and solve that really quick. So again, you want to make sure that your calculator is in end mode. There's no designation up here in the right-hand corner. So we're going to go ahead and plug in 6 for your N, 10 for your IY, 4,000 for your present value, 0 for your payment, and then we're going to go ahead and compute for your future value. So question number 2. So question number 2 is solving for present value. And it says, what is the present value of a security that will pay $20,000 in 15 years if the securities of equal risk pay 6% annually? So, on your test, I'm not going to tell you what character or input that you're solving for. You have to figure that out. So really the key word here is will pay $20,000 in 15 years. So we're going to go ahead and plug our N in as 15, your IY or your interest rate as 6%. You'll leave your present value blank because that's what you're solving for. Your payment is 0 because we don't have one in this question. And your future value is $20,000. So we can go ahead and plug that in quickly into your calculator here. When that comes out, you find out the present value of this for this question or security is $8,345.30. So the first 5 questions are, they're very straightforward. You're solving for your future value, your present value, your interest rate. Maybe you're doubling a sum of money, which is really solving for your N or your period because you're trying to figure out a time. But question 5 down here, let's talk about that one real quick. So it says you have $42,500 in a brokerage account and you plan to deposit an additional $4,000 at the end of every future year until your account totals $300,000 and you expect to earn 10% annually on the account. How many years will it take you to reach your goal? So how many years will it take you to reach your goal? Your first clue should be that you're solving here for N if you weren't given all this additional information. So pretty straightforward. You just plug in your IY, which is that 10%. Your present value, it says currently you have $42,000 in a brokerage account, and you're going to deposit $4,000 at the end of every year until you expect to earn $300,000. So some people ask, do I need my calculator in end mode or beginning mode since I'm dealing here with an annuity? Your key here is that we said that you're going to deposit $4,000 at the end of every year. So that's really the key to let you know that this is an ordinary annuity and that we need to have our calculator in end mode here. So you would go ahead and plug this into your calculator. So we'd plug in 10 for our IY. Today we currently have $4,200. We're going to go ahead and deposit $4,000 into our account. And so if we calculate that, oops, put my negative in the wrong spot there. So we would find out that our N would be 48 years, 49 years roughly. So it would take us 49 years to reach a value of $300,000 in our brokerage account if we put in $4,000 every year. So let's go ahead and look at question number 6. So here we're solving for the future value of an annuity due. The thing that I want to point out here is that make sure that you understand which mode your calculator is in. So in the first question here, it says that we are dealing with an ordinary annuity. So you want to make sure that your calculator is in end mode before you attempt this problem. And then in the second question, it says if this were an annuity due, what would your future value be? So here you really want to make sure that you have your calculator in beginning mode. So if I go up here to question number 1, so I have a 4-year annuity, so my calculator here is in end mode. So I'll plug in 4 for my N, 12 for my IY. I don't have any money saved today, so my present value is going to be 0. My annuity pays $200, and I'm trying to find the future value. So I'll click Compute, Future Value, and my annuity is worth $955.87 in 4 years. Now, if this were an annuity due, remember we need to change our calculator into beginning mode. So we need to go ahead and click We need to click second beginning, second set, and click clear. And now we're ready to calculate an annuity due. So we'll go ahead and plug in 4 for our period, or our N, 12 for our rate, 0 for our present value, we don't have any money today, negative 200 for our payment or our annuity, and then we go ahead and calculate for our future value. So the big thing there, guys, it's an easy question. The one thing that will get you tripped up is the beginning or end mode. So to get back into end mode, just click second begin, second set, and clear out, and that puts you back in end mode. Okay, so a majority of the time you guys will be using end mode on your calculator unless you're dealing with an annuity due. So the questions, if you've looked at the homework or starting the homework, you'll notice that they get much more complex as you get closer to the end stage questions. So question 7 is a great one. In question 7, it's a 2-part question. It's asking what is the present and the future value of a cash flow stream, essentially. So it says an investment will pay at the end of the next 2 years, $250 at the end of year 3, $400 at the end of year 4, and $600 at the end of year 5, all at a rate of 5%. They want you to find what's the present value and then what is your future value. So this is where the cash flow register comes into play on your calculator. So to start this problem, you guys all want to make sure that you're in end mode, and you're going to click here on your calculator. You're going to click cash flow. And to clear out your cash flow register, remember you want to click second, clear time value of money, clear work, and that will have cleared your register for you. So in this question, if you go back to your Word document here, I've broken out those cash flows for you to visualize what it looks like. So you can visualize the timeline here. This is the cash flow register. So remember, the CO means my cash flow in whatever designated year, and the FO means my frequency. How many times did it repeat itself? So I've broken it out here for you, but let's go ahead and plug it into our calculator. So I don't have any money today, so my cash flow sub 0 or today is going to remain at 0. I will, for the next 2 years, have $200. So you're going to plug in $200 for your cash flow, and depending on your level of sufficiency with your calculator, you can plug in a frequency of 1 here or a frequency of 2. If it's easier for you right now learning, just plug in a frequency of 1. If you feel more comfortable with your calculator, you can put in a frequency of 2 and skip to cash flow number 3 if you want. But for simplicity, let's just keep it at 1. So cash flow in year 2, we're going to plug in that 200 and hit enter. Arrow down for a frequency of 1. We're going to go to cash flow in year 3 of 250 and hit enter for a frequency of 1. Then we're going to arrow down, and this is all corresponding here with your document. Your cash flow in year 4 is 400, so you're going to click hit enter. Arrow down your frequency of 1, and then finally your cash flow in year 5 is 600, so you're going to hit enter, and you're going to arrow down, okay? So when you get all those entered, you can go back through to make sure that you have everything entered correctly into your calculator. So when you have that done, you're going to press your net present value button, and you're going to go ahead and enter your interest rate. So over here in your Word document, it says that your interest rate is 5%. So you're going to go ahead and plug that in and hit enter. And then you're going to arrow down to your net present value, and you're going to click compute. So what this has told us, remember, net present value is the same thing as present value. It just means a sum of many present values, okay? So we've solved the first half of this. It says, what is the present value? We know that the present value of this cash flow stream is $1,387.04. Now we have to solve for the future value, and this is really the easiest part of this whole question. We take all of the same inputs, and for our present value, we're going to plug in our net present value from that previous question to solve for our future value. So if we go over here to our calculator, we have a cash flow stream at a rate of 5%. We're going to plug in that figure we just solved for, that 1387.04. Remember, that's negative to us. 0 payment, and then you're going to compute for your future value, and that gives you a value of 1,700 roughly. Okay, so those future, present, and future values of a cash flow stream are a two-part question to solve them. You have to find the present value before you can find the future value. Okay, so question number 8. Question number 8 is a loan amortization question, and it's also an effective annual rate question or calculation for year. So if we take a look at this question, it says you want to buy a car and a local bank will lend you $25,000 to do so. The loan will be fully amortized over 5 years or 60 months, and the nominal interest rate will be 7% with interest paid monthly. So this, like the previous question, is a two-part question. So the first question they ask you is, what will the monthly loan payment be? So you'd think, well, I can just plug in 5 years, 7%, the $25,000 and get my payment. Well, there's a little bit more insight that goes into this question. Does it seem logical that your end should be 5? Sure, it's a 5-year loan, but you have monthly payments within that loan, so truly your N in this question becomes 60 because there are going to be 60 payments within 5 years, so that can kind of get people tripped up. The other thing here, like we talked about in the first lecture, that any time that we have an interest rate that is not annual, that compounds more than annually, you need to use your year calculation down here to solve for that. So in this question it said with interest paid monthly, and so that should have keyed you in that you need to use the year calculation because this is not an annual rate anymore. So before you can solve this first question to find out what the loan payment is, you actually have to find your effective annual rate first to do so. So remember our calculation for year down here. It's 1 plus your nominal rate divided by your period to the power of your period minus 1, okay? So remember, I'm going to take 1, which is that 7% right here. We're going to go ahead and plug that in. And then we're going to divide by our period, and this period here is monthly, so therefore it's 12. It's 12 times during the year. If it was quarterly, it would be 4. If it was semi-annual, it would be 2. So we're going to plug that in there. and we get an effective annual rate of 7.22%. And that is the rate that we're going to use to plug back here into this question. So with the present value of this, remember the present value of your loan today, the bank has given you $25,000, right? So that's the present value of this. Because the future value, the idea of this loan is that in 5 years, after 60 payments, you're going to pay it off, so it's not going to be worth anything. So you can plug all your factors in here, and you can go ahead and solve for your payment. In this question, you can flip your negative. It depends on which shoes you're standing in. In this example, we'll just assume that we're the bank, and so the cash flow, the $25,000 is leaving our pocket. It's negative to the bank's cash flow, but the payment then therefore becomes positive because we're going to be getting that back from the borrower. We're going to get that $1,800 back every month for 5 years for a total of 60 payments. Okay? So then the next question, number 9, is the different periods. So this one's pretty straightforward, and all I'm trying to get you to do here is understand the difference between discounting and compounding, okay? So the first question, it says an initial $300 compounded for 1 year at 6%. It's a super simple question, and when we say compounding, really what we're solving for here is future value. So if I'm compounding, you should instantly think I'm solving for future value. I'm going from today into tomorrow, therefore I'm going forward, or I'm compounding. The second question here says, what is the present value of $300 due in 1 year at a discounted rate of 6%? So if you hear discounting, think I'm taking a future value and I'm going backwards to find the present value of that. And so you're going backwards in time, and so that's discounting. So these problems are not hard to solve. It's the verbs or the verbiage that gets really difficult there for you. So if anything is due, $300 due, that means that that is some amount in the future. So discounting means we're finding the present value, okay? So compounding is going forward, discounting is going backwards, and that's really the reason I put that question in there, is for you to get comfortable with that. So this one, this is also straightforward. We're just finding the present value of an annuity. What I want you to get comfortable with in these questions is being able to flip your calculator into the end mode or into the beginning mode. So this question isn't any different than what you've seen before. You're simply solving for the present value, but what you have to do here is be insightful as to what mode your calculator needs to be in. So in this question, they say we find the present value of these ordinary annuities, okay? So it's saying we have $500 per year for 10 years at 5%. So it's pretty straightforward, right? Our N is 10, our rate is 5%. Remember, we're finding the present value of these annuities, and so that's what's highlighted in yellow here, and our payment or our annuity is that $500, and the future value, remember, if we're not given one, is 0, okay? So we can go over here to our calculator and make sure that we're in end mode, and we can just go ahead and plug this guy in. Plug in 500 for your payment, 0 for your future value, and you discover that the present value of this $500 annuity for 10 years today is really worth roughly $3,800, okay? The next question though, and in your homework it gives you several parts of this question. It's really just practice and muscle memory. The second part of this question though says rework the previous parts and assume that they are annuities due. So an annuity due means that the payment is happening at the beginning, and so therefore we need to change our calculator into beginning mode. So we would go ahead and click second payment, second, and click clear, and now we are ready to calculate an annuity due. So here, same thing, all the same inputs, but our output is going to be just slightly different, right? So it's going to be about $4,000 instead. So again, the lesson here is an annuity due will always be worth more than an ordinary annuity because the annuity due compounds for 1 extra period. Okay, question 11. Question 11 is a perpetuity, and this one gets 90% of students tripped up on a test. Perpetuity is the easiest question I will ask you on a test. The perpetuity, remember, means that this annuity goes on into foreverness. Perpetuity means forever. So the calculation for a perpetuity is very, very simple. It says, what is the present value of a $1,000 perpetuity if the interest rate is 6%? So we take our payment, the $1,000, and we divide it by our interest of 6%. And it tells us that the perpetuity and the present value of this is $16,000 roughly. Okay, so it's a super straightforward question, and it gets a lot of people tripped up. Okay, so let's talk about some of our more difficult questions. So question 12 here in our practice set looks a lot like question 30 and 32 on your homework. So basically, and if you want to pause the lecture at this point, you can go ahead and read this question. I'm not going to read it out loud for you, but let's go ahead and break this question down. So pause and read the question if you need to. So part A says, if Allison's funds earn the same returns as in the future as in the past, how old will she be when she becomes a millionaire? Okay, so let's go ahead and break this question down. We're trying to figure out how old will Allison be when she reaches $1 million in her brokerage account. Okay, so how old is she going to be? So in this question, this is a time question. We are solving for n in this question. So if you looked at the story above, you would know that Allison is investing in an account that returns 8% per year to her. So we would plug in our IY of 8% here. And remember, both of the twins in this question, both of them just received $40,000 for their 30th birthday. So we're going to plug in our present value of $40,000 because that's the money that they currently have in hand. And both twins are going to put an annuity or make a payment towards this brokerage account and add an additional $6,000 every single year. And the goal here is to have a future value of $1 million, okay? So I'm going to come over here to my calculator. I'm going to clear it out. And this is an ordinary annuity because in the question above it said we are going to invest it at the end of the year every single year for a certain amount of time. So we need to go ahead and put our calculators back into end mode. Okay, so let's go ahead and plug this in. So we're solving for n for Allison in part A. So we're going to go ahead and put in 8% for our IY. We currently have $40,000. We're going to put that in for our present value. Allison is going to put in $6,000 a year, and she's trying to get to $1 million. So how long will it take her? So you might think, okay, my answer is 44.5 years. That's how long it will take her, but what we're trying to answer here is how old will Allison be? So if we take Allison's current age, 30, and we add 44.5 to it, Allison is going to be 74.5 years old when she saved $1 million, okay? So then we ask the same question for her twin Leslie. How old will Leslie be if she wants to make $1 million? Now remember, the only difference between Allison and Leslie's situations here is that Leslie invested in a higher rate brokerage account than Allison did. So Allison is earning 8%, but Leslie is earning 10%. So you'll see I've broken out the same inputs down here. They both have $40,000. They both are putting in $6,000 a year, and they're both trying to get to $1 million. But Leslie is doing it a bit more efficiently at a 10% rate of return instead of 8%. So it's the same process. You'll plug it into your calculator just as we did for Allison, and you'll find that it'll only take Leslie 41.6 years to do it. So she will be 71.6 years old when she's saved $1 million. So she does it about 3 years sooner than her twin Allison does. So the last question here says, how large would Allison's annual contribution have to be for her to become a millionaire at the same age as Leslie, assuming their expected returns are realized? So what we're trying to do is we're trying to catch Allison up to Leslie's projection. So that means because Allison's earning a lower interest rate, that Allison is going to have to put more into her brokerage account than Leslie. So we know that it's going to take Leslie 41.6 years, so that's our n in this question. We're plugging in 41.6. It's Allison's brokerage account, which is only earning 8%, so that holds true. Our present value is still the same, and our future value is still the same. It's the payment that's going to change here. So here's a piece of advice. This is why understanding your cash flows are really, really important. The present value is positive because they currently have $40,000 invested today. That's real money. And they're going to put in an additional $6,000 or some amount of money every single year. So that is negative. If you had switched your negatives here, you either would have gotten error, or if you'd put your negative on the present value, you would have gotten a payment of about 40 some dollars, and that's not right. So this is where it's really critical, and that's where you should fact check yourself on these questions. A $40 payment a year doesn't make any sense, okay? So that's why it's important to know where those negatives go. So if we plug all this into our calculator, we find out that Allison, to catch up and have the same amount of money as Leslie in the same time period, instead of putting $6,000 into her account, she's actually going to have to put in $6,700 into her account to catch up to her twin. Okay, last question. So this one, it's a very straightforward question, but it does tend to trip people up because there's a couple extra layers on this question that we haven't seen before. So the question says that you want to buy a house within 3 years and you're currently saving for a down payment. So you plan to put forth $7,000 at the end of the first year, and you anticipate that your annual savings will increase by 25% annually thereafter. So your expected return is 11%. How much are you going to have for a down payment at the end of year 3? So there's about 3 steps to this question. So the first part, you need to use your cash flow register. So remember when we talked about the annuity stream before? To find your future value, you have to find your present value first, okay? So we need to find the present value of this cash flow stream. And it's not as easy as just plugging in $7,000 because there is a piece in here that says that that $7,000 is going to increase 25% annually thereafter, okay? So visualize it, build it out in your timeline. So today we don't have any money, so our cash flow is going to be 0 today. Our cash flow in year 1 is that we're going to put in $7,000 at the end of the first year, okay? But in the second year, that $7,000 is going to grow by 25%. So my cash flow in year 2 is actually going to be $8,750, and that comes from taking $7,000 and growing it by 25% to get that $8,750 figure, okay? And then the cash flow in year 3, we take that $8,750 figure and we grow it by that 25% again to get a cash flow of roughly $10,000 in year 3, okay? So once you get all of those cash flows grown by the correct percentage, you can then plug them into your cash flow register to solve for the present value in this question. So if I clear out my calculator, come over here to the right, we'll want to make sure that we are in end mode here because we are dealing with an ordinary annuity because these are being put in at the end of every year. So we're going to go ahead and click the CF button up here. And just like the previous question, we're going to go ahead and clear our cash flow register out. So second, clear TMV, and then clear work. So we're going to go ahead and arrow down through this. So we're going to go to cash flow in year number 1, and we're going to plug in that $7,000 here and hit enter. And then we're going to arrow down our frequency of 1, and then we're going to plug in a cash flow of $8,750 in year 2, arrow down for a frequency of 1, and then we're going to plug in our final cash flow. Oops. Here, I'll start that one over for you since I messed that up. So we're going to plug in our cash flow in year 1 of 7,000 with a frequency of 1. Year 2, our cash flow is the $8,750 with a frequency of 1. And then in year 3, our cash flow is roughly 10 grand. Here we go. With a frequency of 1. And then we're going to click our net present value button here to bring it to our interest rate. And remember here on the left, our interest rate is 11%. That's what's stated in the question. So we're going to hit enter. And we're going to arrow down to our net present value, and we're going to click compute. So our net present value in this question of this entire cash flow stream, it's actually worth roughly $2,100 today, okay? So then very simply, we take that present value that we just solved for and we plug it into our equation to solve for our future value, okay? So this is a 3-year cash flow stream. So our N is 3. Our interest rate stays the same. It's still 11%. We're going to plug that in for our IY. We're going to take that present value that we just solved for and plug it in. Remember, that's negative. That's cash flow leaving our pocket. Our payment is 0 here, and this trips people up because are these individual cash flow streams, could those be defined as annuities? Absolutely, and they are. But we've already solved for the value of those annuities, which is represented here in present value. Therefore, our payment or our annuity is 0. And then we'll go ahead and solve for that future value. And so we now know that the sum of this cash flow stream, we know the present value of it, and we use that to solve for the future value, and the future value is worth roughly $29,000. And there you go. Those are your practice problems. If you guys have any questions, give me a shout. I didn't solve all the problems for you here. I want you to give them a shot and let me know if you have any questions. But this is a good start, and this tutorial gives you all the pieces you need to solve your homework. So let me know if you guys have any questions.